All right, so this is the same topic again that we have in our ninth. So this is the continuation of that. So what is the meaning of this word polynomial?
Polynomial means poly means 4.
Poly means 4, not 3, not 2.
No.
Poly means multiple, many, and multiple plural starts from
E.
2.
Yeah.
Okay. So nomials. What is nomials?
Um.
Terms or numbers. So anything with multiple terms or numbers is polynomials. And the simplest definition of that, you are aware of the definition? What's the definition of polynomials by any means?
No, I don't know the exact definition.
It's an algebraic expression. This is the simplest version of the definition. It's an algebraic expression and which has multiple terms. Now, what is algebra related to and what's this expression?
Algebra is.
So just dissecting everything.
Yeah, variables. Like.
Which one? Algebraic expression.
Yes.
No, yes for what? Algebraic or expression?
Algebra.
Algebra. Algebra is we have variables. Okay, what does expression have then? What do we study? What is expressions related to?
It's like formation of these variables.
Okay, so in algebra we study addition, subtraction, multiplication, division, and expressions are the terms that you are talking about, which are in turn made up of constants and variables. So expressions are, terms are the building blocks of expressions, and terms are made up of constants and variables. So 2x square plus 3x. So this is one variable. I'm sorry. This is one term, first term, and this is the second term. 3x is the second term, and x is the variable. Okay. Now, if we have maybe 5 here, that's a constant. X is variable. Now, what's the date today?
17 June 2022.
Okay. So just to put it a bit more in perspective, for this month, what is going to be same and what's going to change for this month?
The date and June
June is going to remain same. This is going to change. So this which varies is variable and which remains same is constant. It's just the literal meaning of what these words are in English. Now we use it a bit differently in mathematics. I mean, constants are the numbers 1, 2, 3, 10, 100, and variables are the letters x, y, z, all these. Okay. What is degree?
It is the exponent of a variable.
Highest power of variable, not the constant numbers, variables. So in 2x square, so suppose we'll take simple example, 2x per 1 plus 3. So this is linear degree is 1. It's linear, and we need to remember the standard form for this: ax plus b not equal to 0. Okay, what is the difference between expression and equation? I already told.
Expression
Yes.
is just the things, and the equation is when it's equal to something.
Yes, and the something is also expression. So when expression 1 is equated to expression 2, it is an equation with the equal to sign. So I was asked this in my interview in one company in 2018-19. What does expression? It was in Noida. So I also gave the half baked answer, but okay, I didn't get selected. They didn't select me for some vague English test. Everything else was clear, but the company's reasons to not take candidates, silly reasons. So this phi is also expression because it's a term. So term makes an expression. So 2x. And for the general, I mean, in general, we have these equations common is equal to 0. So 2x minus 2 is equal to 0 because we take everything to the other side. So generally, you can say like it's equated to 0. That also makes sense. But again, 0 is an expression also because 0 is a constant term. But in general, the thing is expression 1 is equated to expression 2. This is linear. So this is a polynomial. We are discussing polynomials. We are not yet reached equations. So I'm not writing equal to 0. Okay. And this, okay. So now 3x square plus 5x plus 6 degree is 2. And that is called which degree 2?
Oh, quadratic equation.
Yeah. Quadratic polynomial. Not yet reached equations. Just to be mathematically right. So the standard form is ax square plus bx plus c. And we need to mind that the variable's highest power should be 2. So a shouldn't be equal to 0. Because if a is 0, then the whole thing would vanish. So we need to take care of that also. Now, not needed, but d3 is cubic. You can write the standard form. And what's for 4? Just for general information, not needed though.
I'm not
Heard
sure
of them?
about
Okay. Biquadratic or quartic, either of them is okay. And so we need to remember the standard form. That is what I needed from this section. Highest power of variable. What is coefficient?
Coefficient is the number before the variable.
Okay. So what is the coefficient of x here?
2.
Okay. What's the coefficient of x?
2.
Okay. The definition of coefficient is apart from. I mean, I made this up, but whatever apart from that, variable that we are focusing on, apart from that, it is the coefficient. So for y, it would be 2x. For x, it is 2y. 2y is the coefficient. Okay, it's not. It's unrelated to the number, just the numbers. You can have variable also. And for what is the variable? What is the coefficient of x?
2x.
Okay, you got it. So this is coefficient. Now, okay, one of the most confusing, important, for some reason silly, where students get confused topic is zeros of a polynomial. We'll try to make as clear as possible, though I tend to make it, but then it's a standard operating procedure. Students get confused time and again. So let's see. So if we have a polynomial, and don't be scared, I'm not scaring you. P.
No, sir, I love this.
Okay, then it's okay. It's an easy thing. I mean, for some reason, students, and not a small number, nearly 80 to 90% students do some mistakes somehow. It is confusing. I don't know why. Now, what is, if we have x as 1, what is the value of this polynomial?
3.
For 2?
4.
And for minus 1?
1.
1. And for minus 2?
0.
For x being 0?
2.
Okay. So, how many values of a polynomial can we have?
Infinite.
Yes, we can have infinite x values, so infinite values. Infinite values of polynomials. Now, this value, where the polynomial value became 0, we are not concerned with x value. Just remember this one thing, the polynomial value should be 0. That's the only concern. Let me make some stars and moons and satellites. Okay. So this x is equal to minus 2 is the 0 of this polynomial. Okay. So if I state, explain it more, probably it might confuse. This is what it is. The px, p polynomial's value should be 0. So now, what is 0 of this polynomial?
2.
So we just equate it to 0 and then solve it. That's as simple as that. Just equate that to 0. Now this is for linear polynomials. It's going to be a lot easier for linear. Now if we have, this. So first and foremost thing, we'll equate that to 0, and then using splitting the middle term, we'd find the factors and then equate
Yes,
to
sir.
0. So just to help you in case you need, this is the these are the factors of this polynomial. Okay. Now there are two things. One is this, another is this. So a times b is 0. So either a could be 0, that means x plus 2 could be 0, or b could be 0. It is a or. It's not necessary that both should be. It's not an and. It's not an and operator. It's a or operator. A little difference between and or. Just like you can eat this dish or that, or eat this and this. So that's going to create trouble. So minus 3. So these are the two zeros of this quadratic polynomial. Now the point is just equate it to 0, simplify, factorize whatever tools you know, and get the values of the zeros. So these zeros, although we'll be discussing again in I think we discuss in the third chapter. So zeros, roots, solution, and for that matter factors also, because factor is related to zeros. If you get the factors, you get the roots, and x value, x or y value. So x values, all these things basically are the same thing, x values, solution, roots, zeros, all these things are same, or satisfies, yeah, another, this value of, what value of x would satisfy this equation. So that's again, the same thing, we are asked to find the x value. So now we'll, okay, I don't feel we should do more of the splitting the middle term. When it comes up, maybe we'll discuss that. So now we are on the 10th topic. Till now it was from the 9th. All right, so any doubts you have, Moita?
No, sir.
No doubts. So geometrical meaning of zeros. Now what we did was, we had px is equal to 0, right? And if
Yes,
we
sir.
take this as y and we make a graph out of these, so okay, so can you tell me when is the y value 0? This is origin, this is y axis, and this is x
When
axis. Can you yeah, can you tell me
when it's on the
why?
x-axis.
Very good. So all the points on the x axis are the values where y is 0. 3 comma 0, minus 3 comma 0, 0 0, 10 comma 0, minus 10 comma 0. So y is equal to
Yes.
0 is this x axis, right? Is my
Yes,
voice
sir.
clear? I mean,
Yes,
any
sir.
glitches? Okay. So that means if I plot a line or any other graph, I mean any curve. So in general we call it a curve for the line also. I mean plotting the curves. So it's a standard thing. Even lines are also called curves. So what would be the 0 of this polynomial? Basically wherever y is 0, px is 0, that is the 0 of the polynomial. And where is that value equal to? It's on this point where it is intersecting with the x-axis. So suppose 1 comma 0, So what does that mean? That means there is 1 0 of this polynomial, because there of this curve, the line, because it intersects only at one point on the x-axis where we have y is equal to 0 or px is equal to 0. Alright. So
Yes,
we
sir.
have 1 0 for this polynomial, and the value of that 0 is x is equal to 1. We can just check whatever the x value is there corresponding to y is equal to 0.
Yes.
All right. So the thing was, wherever the graph, the curve would cut the x-axis, that many zeros are for that particular uh, polynomial. So here it is just 1 minus 3 by 2. So even if you want to check, you can check 2x plus 3. This is the polynomial equal to 0. So you will, when you solve this, you again get this. So algebraically also you get the same value.
Yes, sir.
So now, okay. So the quadratic polynomials, ax square plus bx plus c, this when plotted gives us these kind of shapes, V shape, inverted, or either of these shapes, U whatever you call. Now in 11th and 12th you will study it is sideways also, but just to keep things simple, it is a inverted U or V, whatever you call. Now and these are called parabolas. So it's very common. I mean, any games you play, any games you played,
Yeah.
sports, which one?
And no, like what games, sir?
Any games. You tell me, then I will see if that fits in our definition of this.
No,
Any
like
general
games
games,
as in.
sports, physical activity, sports.
Okay, I played badminton.
Badminton. Okay, that's just fine. So you are hitting this shuttle and it goes this path. That is exactly parabola. Okay. So in the basketball or cricket ball or whatever ball related volleyball, and you have this bullet shooting of bullets, and you have this bridges of arch. That is also. I had a video, but I don't know. I will show you sometime. It's just 1 minute, 2 minute. Okay, maybe I will show you sometime today. So these shapes are parabola, which are basically quadratic polynomials. Okay. Now, how many zeros do these parabolas have?
2.
Okay, 2. Now it is right answer, and you can get the values of x also, the zero values also, and this is x is equal to 4 and x is equal to minus 1. Okay, fine. Now a little additional detail. If this was x square minus 3x minus 4, the a value was positive here, right? A can't be negative anyway. So if you have a positive, it's going to open upwards, the proper u. If the a value was negative, then it would open downwards. All right. So if we had minus 1x square or minus 2x square, it's going to open downwards. All right. So that's okay. Now, how many zeros? Just count the zero number and number of zeros, and just tell me for the first both these figures.
2 and 2.
2 and 2. For these parabola.
1 and 1.
Okay. So assuming it's not, it's a printing limitations. Generally, a lot of students, couple of students say that it is infinite. It's touching this. So we need to be little forgiving to the printers also. So now 1 and 1. And what about this?
0 and 0.
So we generally don't call 0 and 0. We call it as no zeros. It makes it's less confusing basically. 0 0 doesn't make real sense. No zeros. Now, if you have noticed, all these three were very much quadratic polynomials. But in the first case, we had 2 zeros. The second case, for the both, we had 1 0, and in the third case we had no zero. So for quadratic, it's not we have 2 zeros, it is maximum 2 zeros. This is very important. We can have maximum 2 zeros. All right.
Yes, sir.
Okay. So this is a cubic polynomial. This is the polynomial that we have, x cube minus 4x. We need not plot it. That's not in our syllabus, but of course, if you want, you can put the values. That's always possible. How many zeros for this?
3.
3 zeros. And okay, again, forgive the inking issues.
The first one's 3. No, 1, and the second one's 2.
So this is 1 and second one is 2. Okay. I don't know that was visible to you or not. So, okay, so you have 20 seconds to answer all these questions, all 6 parts.
Should I go now?
Yeah.
The first one's 1, the second is
Okay.
2, third is 3, fourth one is 1, 5 is 1, and 6 is 4.
Okay. So that's what the topic is about. The first topic, find the number of zeros, and if you are asked, you can find the exact zero value also. So I positively hope there is no doubt in this.
No doubt.
It is a very easy concept. So what have we learnt till now? Just a moment. We have learnt, we revised few basics of the 9th grade: degree, coefficients, all these definitions, and what are zeros of a polynomial, values of a polynomial. So values can be infinite, but the zeros of a polynomial are limited depending on the degree. And then we discuss about the geometrical representation of zeros, which is basically wherever the y value is 0, px is equal to 0, that is going to give us the 0 value of that polynomial, which means wherever it is going to intersect at the x-axis. So that's what it really means. Now these questions you can try. So now we are on the core topic of this chapter, that is a relation between,
So your screen is blank.
yeah,
Okay.
you like black or you like white background?
No, black is fine. It's just I thought you were showing something and I couldn't see.
Yeah, that's okay. I'm just asking you.
I don't like black.
Okay. A relation between coefficients and zeros of a
But are
polynomial.
you writing something?
For sure.
Because I only see polynomials and a black screen. There is nothing there.
Really? I've written this in white, a relation between coefficient
Yeah,
and
now I
zeros
see.
can't. Okay, it took some real good time. All right. So is the screen not showing up in real time? Like
No, so it was till now. It
just
just
for okay.
didn't show. Yeah.
So what are the coefficient? Ax square plus bx plus c. A is the coefficient, b is the coefficient, c is the coefficient. And what are the zeros? So
For the first
suppose
one, it is ax, the coefficient.
for, okay, I already written it took some time. Can't you see? Not yet.
No.
Really? Okay,
Yeah.
that's strange. That is strange. Let me share my screen once again, maybe.
Yes, I see that.
So these are the coefficient, and if you remember, we did that question: x square plus 5x plus 6. So there we got okay, instead of plus 5x I will take minus 5 for a reason. So if I take this, we'll get the zeros as x minus 2, x minus 3. Is that visible?
Yes, sir.
Okay, good. So if you notice, we have the first zero as 2 and the second zero as positive 3. I mean positive 2 and positive 3. So I'm writing this first zero as alpha and the second zero as beta. Now these alpha beta are just Greek letters, just as we have ABC. So there's just sophisticated version of alphabets: alpha, beta, gamma, delta, eta, theta, all these things. These are just letters, nothing else. So Okay, so now can I write this as x minus alpha and x minus beta for a general case?
Yes, sir.
And there is a multiplying factor k that we'll discuss once we dive it a bit. So alpha beta are the zeros. So now we have to find what's the relation between this ABC and alpha beta. Now if we see ax square plus bx plus c is equal to k x square minus alpha plus beta. I'm just expanding this, and you know if you want I can show the intermediate step also. So let me write it also.
No, sir. I know this, sir. It's okay.
You just open this up and then take the x common. So you'll first, this would be a negative term, this would be a positive term. Now this is a very important that form that we need to remember. If we are given the sum of the zeros and the product of zeros, so this is what we need to use. So this is the first thing that you need to remember. Now because you can't put in the alpha and beta values, right? Alpha and beta is not equal to sum of alpha and sum of alpha beta, so that's different. So this is first thing. Now if you compare this, ax square is kx square, bx is minus k into alpha plus beta. K again is getting multiplied here, same for the c case also. C is equal to k alpha beta. Now if this is so a would be equal to k, and now this value I'm substituting here. So b is equal to minus a alpha plus beta. X is removed, so alpha plus beta would be minus b by a. This is our first relation between the zeros and the coefficient. So this is sum of zeros form. Sum of these two zeros, alpha plus beta is equal to minus b by a. B and a are the coefficient, and there is a negative sign, very important. Coming to the second one, if this we substitute as k,
Alpha by beta is equal to
so
C by A.
alpha beta is equal to c by a. This is the product form, product of zeros. Product. So these are the three things that we need to remember, and if you remember this three things, probably the whole chapter is done. I mean, we'll do some questions, but this is what it is. Any doubts?
No, sir.
All right. So let's try the fourth question. Now find the zeros of the quadratic polynomial. So we'll split the middle term and find the zeros. So alpha beta values would come from here, and then we need to verify the relation between zeros and coefficient. So we need to use that identity we just got. So get the value of alpha beta first.
Alpha and beta are minus 5 and minus 2.
So x square plus 5x plus 2x plus 10. The sum should be equal to b. Sum of the two numbers should be equal to b, which is 7, and the product should be product of the two numbers that we are dividing into is a into c, which is 1 into 10, which is 10. So we got this and we solve this, we'll get the two zeros. Now what's the relationship between these? So alpha plus beta, the sum of zeros is minus b by a. So what is ABC values from here? What are the ABC values, coefficients
Smart.
of this quadratic polynomial? I'm just asking the coefficients a, b, c. What are the values?
X 1 5
A is 1, 1x square. B is
5.
B is 7. I mean, this is the quadratic form.
Alright,
So,
sorry, 7.
sorry to confuse. C is,
Oh, and 10.
so these are ABC values. So now let's start with the LHS. Alpha is minus 5. You took minus 5. Beta is minus 2. So LHS is alpha plus beta, the sum. So what is alpha plus beta? Minus 5 minus 2, which is minus 7. Now let's take the RHS, which is minus B by A, which is minus of 7 by positive 1, which is minus 7. So this is verified. The first identity is verified.
Yes, sir.
Second is alpha beta is C by A. So just try that.
Yes, sir, 10 is equal to 10.
So alpha beta value is minus 2 into minus 5 into minus 5, that is minus 5 into minus 2, that is 10, and this is also 10. So okay, let's try this. Get me the ABC values, very important, and get the alpha beta values. Rest is easy. And one thing, because it's a quadratic form, we need to get two solutions. Like root of 4 is positive 2 and negative 2. Now we are in 10th, so we'll have two values. Till 9th it was okay, but now we have to get two values for any chapter, not only for this chapter, for any chapter. So what is the value of A, B, and C?
Yes, sir, 1 minute.
Hint is to compare with the standard form.
Yeah, I've done that.
Yes, no?
Uh, the splitting of the middle term and stuff, right?
There is no middle term in this. Okay, what is A value?
Oh. Oh. So A value is 1,
B value is
0,
okay. C value is
3.
negative 3. You might be hungry, but don't be for negative and negative signs. So this is ax square 1x square plus 0x minus 3. This is what we have. Now, what are the zeros? How do we find the zeros of any polynomial? Equate that to 0. So what do we get? X equal to
Mm, 3 minus x. No, 3
3.
by x.
X square is 3, so x would be
3 by x.
okay. Square root of 3. Square root of 3.
Oh,
Okay.
yes, sir.
Epiphany moment. So
Yeah.
this is plus minus. So we have one value is negative root 3 and another value of 0 is positive root 3 and negative root 3. So alpha is root 3 and beta is minus root 3. Now hopefully everything should be fine. Just try.
Yes, sir. Yes, sir, both are 0. Yeah.
So first relationship, alpha plus beta is root 3 minus root 3 is equal to 0 and RHS is minus b by a, which is minus 0 by 1.
0.
Second is alpha beta. Alpha beta is root 3 into negative root 3, which is negative 3, and c by a. C by a is minus 3 by 1.
Which is
Okay. All right. So let's see how good you paid attention to the class or how good is your memory. Yes. Or maybe you are good at taking notes. Either three might work. So what do
yes,
we
sir.
need to do?
It's the formula, the k for bracket x
Okay.
squared,
Kx
uh,
square my
alpha plus
and
beta x
minus
plus.
alpha plus beta x plus alpha beta. Okay, good. Good for either of the three cases. Now k times x square minus, what should I substitute?
Minus 3.
Plus
2.
so x square plus 3x plus 2. Now this k value could be taken as any real number, any real value. So you can take 1 just to keep things simple. So you get the
Yes,
standard,
sir.
I mean what we generally see, x square a is 1, and you could have it as minus also. I mean you could have minus 10. You could have it as minus 1 by 2 also. Even worse, you could have this. So all of this works. Now,
Yes,
where do we
sir.
get these things? In some cases, you might get a common denominator for these three terms, x square plus 3x plus 2. So that you take out, and that you say, okay, this was something was k here. So you get a more aesthetically pleasing equation. All right. So
Yes.
now I had one thing. Yes. Now tell me if you can get the roots of this. Probably x is alpha is minus 2 and x is minus 1. These are the two roots probably you will be getting from these two set of equations. Yes, minus 3 and product is positive 2. Now tell me if I multiply this by 10. So x square plus 3x plus 2, and I get the second quadratic polynomial 30x plus 20. Now can you tell me what are like zeros for this? The first case yielded us these two zeros, and what would be the zeros for this? Would that be same as minus 2 minus 1, or would that be different for this second form?
Different.
Different. Okay, good. That's not the case, by the way. If we multiply by 10, it's just a multiplier. It doesn't really change or alter the values of alpha and beta. Even if you have 1000 x square here, 3000 x, 2000, it is still going to give us these very zero values. Okay. So if you change the k value, the alpha beta values or the sum and product is not going to change. All right. Just mind that point. Seventh one you can try yourself, it's related to this. Eighth one you could do yourself, I mean same questions. First one was to verify the relation of that, and second eighth one is to generate the quadratic polynomial. So I don't feel that's going to be difficult. Ninth, so probably half an hour more and we'll do this chapter completely, maybe even less than that.
Four by 3.
Yes. So if one of the zeros, so one of the zeros means it would satisfy this polynomial. It's going to give us a 0. Px is 0. So P of
Yes,
alpha
sir.
is also 0 and P of beta is also 0. Both the zeros would give us a 0 value. And if we just solve it, you will get some equation, and on simplifying, we'll get this value. Now this is interesting. Let's see.
D.
Sad
2x square
emoji.
plus 2. Why?
That's not right. For some odd reason.
If if k is equal to 2, then it will work.
Okay. Mind the negative sign if that hint works for you.
Yes, sir. Even if it is negative. So, and the equation you get is x squared plus x minus 12.
Plus plus
No,
12.
minus 12.
Okay. And what is this? Okay, what is the standard form that you use to frame this? Any of these? One, two, whatever. What did you use? K times
K x squared plus, oh,
x square plus.
the minus alpha plus beta x
Okay. Okay. And
minus alpha
plus or
beta.
minus? That's plus alpha beta. Okay.
Yeah.
Ask your mother some almonds. Okay. So now what do we get? You can change your verdict.
X squared minus x
Hmm.
minus 12.
Okay. So
It's
still
the,
it's D,
let's see,
because if we take K as
1 by,
half, this is what you're going to get. Okay. So hope you got this.
yes, sir.
So you, because you're done with the third chapter, so try the 11th question also. I mean, it's not really related to third chapter, but see, concepts were only these few concepts. Geometrical representation of zeros, the relationship between zeros and coefficients, and the standard form. These are the only three things. I mean, now it's a mix of questions, nothing much. Okay.
Yes. A is equal to 0 and B is equal to minus 6.
A is equal to 0 and B is equal to
Minus 6.
minus 6. Okay, how did you get that?
Uh, so 2 minus 3.
2 minus 3. Okay. Reason? What's the reason? 2 minus 3.
2 minus 3 because A plus 1. And the zeros are 2
Okay,
minus
so you are
3.
comparing the given form with the form derived from the given zeros. So x square minus 2 minus 3, which is minus 1x minus 6, alpha beta. So if we compare this, we are going to get a plus 1 is equal to 1. This is a positive. So a is 0 and
And
then
that's
b is
0.
negative 6.
And that is
Okay, tell me.
1.
I thought this thing
No,
is
no, no.
done and dusted.
More than 3.
You can have infinite values of k giving us the same zeros, right?
Because
If you multiply by
yeah.
10 anything, 10 hundreds, the polynomials would be different, but the zeros would be same. Okay. Cubic polynomials we don't have, so 13th question, 14th question is not there. Before coming to these 4 questions from 15, 16, 17, 18, I would just see if you have any simpler questions. So try this 19th. I mean, just read it and tell me what you have to try.
First we find the zeros. And it's a factor.
It's a 9th grade question.
Just
Came in boards. Okay.
so x is equal to minus a.
Yes. So it's a factor theorem. If we have this as factor, suppose x plus 2 is the factor of something, then x is equal to minus 2 would give us a 0 for this polynomial, right? So
Yes,
you
sir.
substitute x is equal to minus a in this equal to 0 because it's a 0 factor, zeros, everything is same, roots. So you will get some value of the missing variable. Okay, 20. So easy.
Yes, sir. This is also like how we did because they are the zeros.
Yes.
A plus b. I mean, sorry. Alpha plus beta is equal to minus b by a, and
Okay.
alpha into beta is equal to c by a. So by using that, we find what's alpha plus beta and alpha beta, and we find the value.
Okay. So although you did it right, but never underestimate this too. I mean, the a value. If it is 1, then you can write okay minus 7, but we need to be little careful. Now the important part is which would which might be asked is, suppose you are not given this form, you are only given the sum is 3 and product is 2, then what to do? So you might think it becomes way easier than the earlier one, or maybe not. No. Okay, sum of two zeros is given as positive 3 and product of two zeros of this polynomial, any polynomial is given 2. We have to find the value of alpha plus alpha beta. So, okay,
3 plus 2.
that's it.
Yeah.
Alpha plus beta is 3 and product is 2. Now, this sounds silly for this question, but this is the deal. Sum is 3 and product is 2. Okay. Expressions are changed. So clearly you can't get alpha and beta values, right? For this. I mean, you could do something, but then leave it. So what to do? You have to just, we are just given alpha plus beta sum as 3 and alpha beta is 2. Further, a hint.
Alpha is equal to 3 minus beta.
Okay. We'll try to keep our life simple. Just take the LCM.
Oh.
Okay.
Yes, sir, that
So
has sense.
you can do all this fancy stuff, and the point is you are given sum and the product only. Sum and product, not even the difference. Now, the important thing is this. Okay, before that, okay, leave this question. We'll come to this later on. What would be this value? Find this value using the sum and product, only the sum and product. Alpha plus beta is 3 and alpha beta is 2. Do you know any way to convert alpha square plus beta square to sum and product?
Using the formula,
Any
the identity.
magical? Yeah, okay, you got it. So which one?
A square plus b square is equal to
So this is our first identity for square identity, the a plus b identity. So if we want only the value of alpha square plus beta square, we'll get alpha plus beta whole square minus 2 alpha beta. Right? Now we only have the sum and the product. So now it's way easier to solve. 3 square minus 2 into 2, which is 5.
yes.
Is that okay? So alpha square plus beta square was not there, and we are only given the sum and product. So we converted using the first square identity, algebraic expression identity. And now, what is 1 by alpha minus 1 by beta? Only this thing is given. So we are solving next 3-4 questions in one question only, just to save time, and it is more comprehensive. You get it a lot better. Yes.
With finding the LCM.
Okay, that is the first step. So b beta minus alpha divided by alpha beta. Okay, still we are not getting rid of this negative thing. It's way too negative.
You square it.
Maybe
You square it and use the other identity.
that is intelligent. So we square this. We, at the end of that, we'll just take the square root, whatever answer we get. Now if we are squaring it, we'll get b square plus alpha square minus 2 alpha beta
minus 2.
divided by alpha beta square. Okay, that was good. Okay. So you already have this alpha beta, this thing, alpha square plus beta square value. We just found,
And
you
that's
know, a
Quartic.
plus b square minus uh, 2 alpha beta. So this first value, although we found it, I mean, you can substitute the answer also, but this was alpha plus beta or beta plus alpha square minus 2 alpha beta. This was the value of alpha square plus beta square, right?
Yes,
And
sir.
then this minus 2 alpha beta extra divided by alpha beta whole square. Okay, so you will get alpha plus beta square minus 4 alpha beta, and now it is in product and sum form only, whose square root you could take at the end. Okay, so
Yes.
you did it, you know, the other way. I mean, that's absolutely fine. The thing was alpha minus beta value is equal to alpha plus beta whole square minus 4 alpha beta. This is the identity, I mean, the formula, if you call it so. All right.
Yes, sir.
And there might be questions where you need alpha square minus beta square. So alpha plus beta, alpha minus beta would come from this, and alpha plus beta is already there. So there are unlimited situations. Okay, let's get two more hypothetical situations.
This
It's
is
the
the
same
other
concept.
one.
Yeah, that's it. So it's
Yeah.
using the, you know, cubic
A,
identity. So
yeah.
alpha plus beta, a plus b, and a square plus b square
B
minus
square
ab, and if it was negative,
minus A.
so we would have taken alpha minus beta, and alpha square plus beta square plus alpha beta is the same thing, identity.
Yes,
Now
sir.
this value is already there, we just found. Alpha beta is already there, alpha plus beta is already there, alpha minus beta is already there. So any variations you could do. Okay, so maybe one level up, alpha 4 plus beta 4. Okay,
This is also the same.
it is the same, but I don't feel you got it. Maybe you got it, but I don't feel you got it. Just tell
Alpha
me, you
plus
need to explain.
beta.
Okay,
Uh,
so here we take alpha square plus beta square. I would given you more time, but just to save some time. Now this is x square plus y square form.
yes, sir.
So what is this? This is x plus y square minus 2xy, which is alpha square plus beta square minus 2 alpha square beta square. So this is product square, alpha beta square. Now that is okay. So this is done. Now this we already know. We just found alpha plus beta whole square minus 2ab. So you just substitute the value. Okay, alpha for 4 plus, not minus. Okay, you can do it for minus if you want. It will be alpha square minus beta square multiplied by alpha square plus beta square. And okay, whatever. I will not write, but you can even do for alpha power 8 and beta power 8 also. But that is overkill. Okay. So the important part was this, alpha plus beta square minus 4 alpha beta using the identities. Okay, that was the important part. If you are given the quadratic polynomial, then you can find anything. I mean, just substitute the alpha beta value. You can factorize this, split the middle term. You will get the values. Right.
Yes,
So
sir.
you just put the value of alpha and beta. No need to do that whole algebraic thing. But if the polynomial is not given, if you only given the sum and product, then we have to take all this trouble. So if it is polynomial is given, that it's kind of a, you know, piece of cake. then it's easy. But otherwise it's little we have to have a workaround. Okay, 21, you try yourself. Not going to insult your intellect. 22 is, see, the quadratic polynomial is given, so you can find the zeros, just substitute the values. Okay, this one is easy. So I gave you, if the sum and zero was given, sum of zeros was given and product of zeros was given. So again, the alpha beta values are, we can find it out from the this thing polynomial and then substitute alpha beta. Very easy. So I changed this question. This was not initially sum is 5 and 3. This was something else. The polynomial was given, but I changed it to make it little complex. So it's the same thing. Okay, minus that minus identity. Okay, you try this. Last two questions are based on simple questions. Now we are left with 4 important questions. Probably you'll get it pretty quickly. These are MCQs. So now again, we studied geometrical representation of zeros, verification that 2 identities and 1 standard form. The standard form is very important. I mean, that is the first priority of this chapter. It's that important. Okay, so now coming to this 15th question. Maybe it will take 5-7 more minutes. Yeah, not for this question, rest 4 questions. Okay, try this. Don't have to go, right? Any other engagement?
No, sir.
Okay. Because we'll just complete it, you will save time for tomorrow, na? You can revise.
Both negative.
Yes, both would be negative. Reason being?
Because when you find the split the middle term and find it, it would be positive. So when you find
Okay, that's possible. So you anywhere you have a big number, you can take a smaller version of that. X plus 2, x plus 3. We did this question, so both are negative. But in general, the another concept that you could use, which would be helpful in the next questions, is sum of 2 numbers. Sum of 2 zeros is negative 99 by 1, which is a negative number. And the product of these is a positive number. So when can we have the sum of 2 things negative and their product positive? When can we have? Sum of two numbers is negative, but their product is positive. So product is positive for maybe plus plus and minus minus, right?
Yes, sir.
And if we have the sum negative, so surely they can't be positive numbers. So both should be negative. Is that okay, or was that quick? Too quick?
No, I just didn't understand.
You didn't? What?
Understand.
You didn't understand. Okay. So there are 2 numbers. Not only for this is alpha beta for the zeros. I'm asking any 2 numbers. You can take any 2 numbers. The sum is negative. Sum of those numbers is negative. And their product is going to be positive. How can that be? So product is positive only in these 2 cases. Both the numbers are positive or both the numbers are negative. Right?
Yes, sir.
But now they are, it's mentioned that sum is negative. We found that. So sum can't be negative from the first case, right?
Yes, sir.
So both of them should be negative. I hope it's all right this time.
Yes, sir.
Okay. So So either way you can use some rough values also, trial and error, or you could be a little more specific, uh, more mathematical. So now 16th. Again you can take some values of k, positive, negative, two different cases. K is not 0, so you can take positive, negative values, two cases, and then try to solve this.
Sir, A and B means the same thing.
Which A and B?
The options cannot both be positive, cannot both be negative.
Cannot both be positive, cannot both be negative. See, cannot both be positive means, okay, we'll have some examples. You tried any example?
X squared plus x plus 1.
Okay, even that would work. So you took k as 1, and then another case you could take k as negative 1. I generally take 4, so that makes my life a little easier. So you want to stick to 4 or 1?
4.
Okay, 4x plus 4. So this is x plus 2 whole square. So zeros would be x is equal to negative 2 and negative 2. So both cannot be negative is not true. It can be negative. It can be negative, right?
Yes,
Okay.
sir.
And for the second case, always equal, so always unequal, even that is gone. B and C options are not working. They can be equal also. Okay, now let's come to the case 2 where we have minus 4. So x square minus 4k minus 4. Now you have to use quadratic formula, otherwise you'll get stuck. And you have not studied quadratic formula. Okay, so you will get two values. I'll just tell you the quadratic formula, and it would help you understand the question and finalize the option. But that's in the 4th chapter that you will be studying. So x is found by minus b plus minus b square minus 4ac. All these are the coefficients of the quadratic form. So minus b is minus of minus 4 is positive 4, plus minus b square is 16 minus 4 into ac, 4 into 1 into minus 4. If anything is not making sense, that's okay, but just beware of the final options. So we get x value as 4 plus, this is plus minus, so 4 plus 16 plus 16 root 32, 2 root 32, 4 root 2, 16, yeah, and 2. So this is our first answer, first x value, and the second x value is going to be 4 minus 4 root 2 by 2. So we got two values, okay, and these values are not same. One is with positive, so second one is with negative. Both answers are different. All right.
Yes, sir.
So they are always equal is also not right. Okay, just a moment. So we tried two examples, I mean two values, one for positive and negative. So with positive, it is pretty straightforward. We eliminated two options, B and C. But from this negative value of k, we got two non-equal roots. Solving part is, not, you might or might not get right now, but these are not clearly equal. So we can get unequal roots also. So that is, D option is also gone. So option A is our right answer. All right. Tricky. Then the question. You got it or not?
Yes, I got it.
Oh. One note is stuck. One note doesn't want to continue. We have just two easy questions left. But where are those? Okay. Yeah. There's 2-3 minutes more.
Sir, are you showing a question?
I'm trying to.
It's
Let
black.
me. Yeah. Okay, now it's
Yes, I can see.
visible. Again, you can take some examples, taking cues from the question, and then try this. So what to try? What are you trying?
4.
4?
X squared plus 4x plus 4.
Roots are equal. So you could have started with the roots being equal. So you took 2, basically. That's what I understand. Right? Roots are equal. Zeros are equal.
Yes,
So
sir.
you will get x square plus 4x plus 4. Now you should also take another case with negative zeros. We'll come to that later. So now, yes, C and B have opposite signs. C and B have same signs. Which one out of these is true? So we must get, okay, first is this. Second one from the negative is what? X square minus 4x plus 4. Correct? You have to consider both sides of the coin. Okay. So now decide if there are equal roots, which out of these is invalid. C and A have both opposite signs. Is that possible?
No.
No. C and B have opposite signs. Is that true? Always?
No.
No. C and A have the same sign?
Yes.
Yes, always. D option, C and B have the same sign? Not necessary.
No.
They can have opposite signs also. So option,
C.
is that okay?
Yes, sir.
So we should take some extreme examples, and it should be, both negative and positive. All right.
Yes, sir.
And if you want to use this, minus b by a, this thing, and alpha square is equal to c by a, so even this probably, this is plus, okay, plus, so even this might help. So alpha square, alpha is root of c by a, so root of c by a means c and a should have the same sign, otherwise it would be a negative square root, correct?
Yes, sir.
It could be positive c by positive a, then the root would be a positive number, or it could be negative c by negative a. Either of the cases, a and c should be of the same sign. Okay, so this is a technical way to do this, but whichever suits you. Okay, last question for our chapter from my side. 18th. This is easy. Just follow what's given in the question.
Yes, I don't see the question yet.
Okay, wonderful.
I see now.
So what have you tried?
So the sum of zeros is minus b by a. Product of zeros is c by a. Mm, the zeros are
Hmm.
alpha and nine
Minus y minus what is this?
negative.
So Take some example, that's it. So alpha is, what do you want to take? Alpha value is which number?
Four
Okay. So beta would be?
minus 4.
Okay. Now even if you want to switch, this is going to be the same thing. It doesn't really matter. So there is only one case, right? Now solve this further. How to form the polynomial? Alpha is 4 and beta is minus 4. What's the polynomial going to be?
So 0.
What 0?
A is 0
How?
because
Okay. This A. Okay. You're saying this A is 0.
yes, sir.
Okay. So k into x square minus 4 minus 4 times x minus of 4 into 4. So k is 1. Okay. 1 into x square 0 minus 16. So now which option is true? A, B, C, D.
A.
Easy.
Yes, sir.
If there are any unknown variables which is confusing, I mean, it is not that obvious, intuitive for a lot of cases. So get some numbers, and the values should be generalized. Don't take for the kx plus k question above just did. So we can't take only one value. Otherwise, you might get some equal roots, and then you'll get away with that. But take some generic values, that generalized values, and then try it. So one positive value, small positive value, plus 4 plus 16, no? And minus 4 minus 16, something like that. So that would help. So this is from my side. If you have any doubt, please ask. It was quite a class. I mean, quite a lot of topics, a lot of questions in one go. But I don't feel it is difficult. I mean, apart from few parts, other areas, 90% of the areas are just straightforward. So
Yes.
any doubt, please ask.
No.
So in that case, you try the 7th, 8th question and the last two case-based questions. In addition to this, whatever questions we did. So just revise this, and if you get time, I don't know, you can go to the PYQs also. Cubic questions are not there, so just be careful in the PYQs if you reach there. Apart from that, if you do this probably 2 times the worksheet, maybe 10 to 15 questions that we did 2 times, that's sufficient. Okay, so we'll continue. Let's see how things go, and if you are having any doubt, you're solving, you're getting stuck, please shoot me a WhatsApp message, and with the image of the question solution, whatever you are attempting, and I would help you with that. Okay.
Yes, sir.
Okay, so we'll see you on someday. I mean Monday. I don't know, Monday or Tuesday. So we'll continue. Okay. Okay, boy. Bye.
Bye, sir. Thank you, sir.
Yeah.